Alright, I hope to get a lot of this done, but there are people crawling around this house, aka my kids. So the first lesson in Unit 3 is about polynomials. I'll start with adding and subtracting. So basically with adding and subtracting, the goal is to combine like terms. Like terms, same variables to the same exponent. You could do this in a bunch of different ways. I like to teach how to do this using what I call a stacking method. You have two quantities with a plus or a minus sign in the middle. If it has a plus sign, it's very straightforward. I take the first quantity and I copy it down. So we have 9x to the third plus 9x to the second minus 2x plus 5. And I stack these underneath with like terms. So 4x to the second power obviously goes under this 9x to the second. This 8x goes underneath the negative 2x. And this 3 goes underneath the 5 because numbers are like terms. And then all you do here is you add the coefficients, keep the variables to the same degree. So we have 9x to the third power. That just can be copied down. 9 plus 4 is 13. Keep your x to the second. Do not change your exponent. Negative 2 plus 8 is 6. And 5 plus 3 is 8. Okay. This next one, there's a minus sign in the middle. When there's a minus sign, you change all the signs to the right. So in this case, all I'm doing is I'm looking at the signs inside of the quantity, sorry. So 7 is positive, 2 is positive, and 9 is negative. So you're going to change every single sign. So the 7 is going to become negative. I'm going to write a little sign above it. The 2 becomes negative, and the 9 becomes positive. Once you change all of your signs, I'm going to change this minus to a positive. Basically what we're doing here is distributing a negative 1 through. A negative 1 would change all of the signs. Everything else is straightforward. We have 11x to the third power minus 4 plus negative 7x squared minus 2x plus 9. Since I have such a difference between, we have an x to the third here and no x, I'm going to leave a little bit of space. So I have an 11 x to the third power minus 4. Just to save space if there's an x squared, x, etc. So negative 7x squared should not go under either 11x to the third or negative 4. It should go by itself, but it's x squared. So if we're going in descending order, x3, then x2 will come next. And I have negative 2x. Again, that shouldn't go under any of this because it's not a like term. So I'm going to put it next to the x squared. And this plus 9 should go underneath the 4 because they're like terms. So if they don't have like terms, it's hard to do this and hold this and not have the paper move on you. So we have 11x to the third minus 7x to the second minus 2x plus negative 4 plus 9 is 5. That's how we do problems like that. Here's one a little bit bigger with your subtraction, sorry. So again, you're going to take all of the signs here and switch them. So instead of a negative 8, it becomes positive. This negative becomes positive. Positive becomes negative. This positive becomes negative. Once I change all of my signs, I'm going to change this negative to a positive. I don't know what's on my finger. Oh, I think the pencil. So I'm going to take this 2x to the fourth plus x to the third minus 2x to the second plus 4x. Thinking about chicken nuggets. Now I'm going to put all of this underneath it's like terms with the new sign. So plus 8x to the fourth. Then I have a plus x squared, which is like 1x to the second power, minus 3x, minus 9. Drawing a line. Sorry, I was holding the paper. Straight line. 2 plus 8 is 10. X to the fourth. This positive x to the third comes down. Negative 2x squared or plus 1x squared is negative 1x squared. When I could write it like this, or I could have written it as minus x to the second power. And it probably will be, well, not probably, it definitely won't have the 1 in front of it. Okay? So plus 4x minus 3x is plus 1x, but again, the 1, you don't need to write it down. And 6 minus 9 is negative 3. And I believe that that's all I have about that. Yep. So that was adding and subtracting polynomials.